Okay, so I would like to show a few more examples on the application questions using roots of equation. So the first question here, this is taken from your textbook, yeah? Question 5.15. As depicted in this figure, the velocity of water discharged from a cylindrical tank through a long pipe can be computed using this formula. Given G, 9.81 meter per second squared, so this is the gravity. H, the initial head, which is in meter. L, the pipe length, also in meter. T, the elapsed time. And determine the head needed. So determine the head, which is the H. To achieve velocity 5 meter per second in 2.5 seconds for a 4 meter long pipe. So 4 meter long pipe is the L. So L here is 4. Graphically, bisection, and using false position. I'm more interested into bisection and false position. And then employ initial guesses of XL equals to 0 and XU equals to 2 meter with a stopping criterion of PS equals to 1%. And check your results. So what you can do is, in order for you to use bisection and false position, you need to transform this equation into a function. So it has to start with fx equals to something. Okay, in order for you to do that, what you can do is you can actually bring this v to the other side of the equation, and this should be minus v. Then becomes fx equals to this whole thing minus v. Something like this. Okay? And then substitute the parameter values, all the values given, that will give you this equation. So 2, this is g, substitute the g, and then h, this is what you are trying to work out. So you are actually very familiar with x and fx, but in this case the x is h and this one is fh. Alright, so fh equals to this whole thing, and then this is the one that you are trying to solve, and then 10, and then this thing, and then we have h here, and this one is 4, which is the L, the length of the pipe, which is 4 meter, times 2.5 minus 5. Why 5? Because given here, the velocity is 5 meter per second. And then once you've got all this starting equation, you can solve your bisection and false position method, and you can employ the value of the initial guesses XL and XU. So in this case, this is HL and HU. And then stopping criterion 1%. I want you to try this on your own. I'm just helping you to understand this question on how to begin with. Alright? And then next is the question asks you to check your results. How are you going to do that? Let's say after a few iterations, you found that your EA already less than the ES, you can stop, and whatever H value that you got in that iteration, that will be your final answer for H, correct? For H. And you can then substitute your final answer back into this original equation. Just substitute back the H into this original equation and see whether you can get V equals to 5 meter per second. Of course, you wouldn't get 5. You will get a value which approximate to this value, which is close to this value. So try this on your own. Next question. Water is flowing in a trapezoidal channel at a rate of Q equals to 20 meter cube per second. The critical depth Y for such a channel must satisfy the equation given here, where G is 9.81 and AC is the cross-sectional area, here this one, and B is the width of the channel at the surface. So for this case, the width and the cross-sectional area can be related to depth Y by given here B in terms of Y and AC in terms of Y, the question wants you to solve for the critical depth Y. So the unknown here is Y using graphical method, bisection and false position. Again, I'm more interested into bisection and false position. Okay, then use initial guesses of 0.5 and 2.5 and iterate until the approximate error falls below 1% or the number of iterations exceeds 10. So it's either your EA falls below 1% or you reach the maximum number of iterations, whichever comes first, and then you can stop your calculation. And then what is the starting equation? You can use this straight away because this one is already equals to 0. So your fx will be this the whole thing, something like this. So in this case, it's not x, it's y. Your fy equals to 1 minus 400 is from this q, this one, q squared, meaning 20 squared. So this is 20 squared, alright? Divided by G, 9.81, and this one is AC, this. And B is 3 plus Y. So this will be your starting equation for both bisection and false position. Alright, next is the last one. You are designing a spherical tank to hold water for a small village in a developing country. The volume of liquid it can hold can be computed as this. Given here, V equals to volume, H equals to the depth of water in tank, and R equals to the tank radius. So given if R equals to 3 meter, to what depth, which is the H, must the tank be filled so that it holds 30 meter cube? So this one is V. Use 3 iterations, alright, only 3 iterations of false position to determine your answer. Determine the approximate relative error after each iteration. So this is very simple. You only need 3 iterations and you have to calculate the EA. Employ initial guesses of 0 and R. What does it mean? So R here means 3. So your initial guesses is 0 and 3. You need to transform this into a function, something like this. So you have FH, because this is what you're trying to solve for, and then pi RH squared minus pi over 3H cubed minus V. Why minus V? You actually bring this V to the other side of the equation. So that's why minus V. And just substitute all the values of R and V in this equation. R 3 meter, V 30, and then you can start solving using the false position method. Thank you.